Okay, so we've come a long ways on our understanding of hydraulics in just a short amount of time. There's a couple of things left that we just need to kind of police up so that way we're all kind of tracking, because we're going to end up having to do a lot of hydraulics maintenance, both with landing gear, with flight controls, and a variety of other things in the future. They all have some of the same characteristics and same components that we need to be familiar with, so that way we can be effective mechanics. So we're going to talk about like seals, filters, and accumulators in this video, and kind of give an overview of what the core tenets of those devices look like, and what does servicing and maintenance look like for them. Should be pretty short. This should be an easy one for you guys. Okay, so before we start breaking down packings, gaskets, and wipers as different types of seals, let's talk about some basic rules of the road when it comes to changing out aircraft seals. One is, if you remove an aircraft part that has like a packing, an O-ring, or something like that on there, you need to get a new one whenever you go to reinstall it. Now, there's a lot of reasons for this, but the primary one is that, like, whenever you install and use a gasket of some variety, or a seal of some variety, and then you remove it, you're going to fundamentally shift the way, or fundamentally change the way that the packing or seal or O-ring or whatever is shaped. So one of the clearest examples of this that I could ever see came from this big, like, 6-inch packing that we used to put around the fuel port on the OH-58. So what we would do is that to get it on there was kind of a bear. You ended up having to use a lot of it's petrolatum, but basically it's a KY jelly, and to get it in there to make it fit, and then you would install it. And after it was exposed to fuel, whenever you pulled it back out, it would be too big to get back into to the ring that it was supposed to sit in to help seal that fuel cell up. So it went from being too small to too big just by simple exposure to the liquid that it was supposed to help contain. And that is just a reason why you always use a brand new packing anytime you're going to do maintenance. So that should factor into your maintenance planning, that if you're going to do a bunch of maintenance on something, and you need to look through and see, like, is there any packings that I have to replace, and order that with your parts, or have them on hand, or what have you. Because what you don't want to do is get into the habit of, oh, I'm just going to put it back on there, because what will end up happening is that over time, that packing that, like, now has been, misshapen by use, it's not going to sit back into the area that it's supposed to seal correctly, and then over time it will eventually start a leak. That leak could then add on to a bunch of other problems, and next thing you know, you have a 15, 20, $100,000 issue that was literally caused by a 25-cent O-ring that you were just too lazy to swap around. So always use new ones. When installing them, like I said earlier, you can use like KY jelly. There's other petrolatum was the military term for it, because that's the actual chemical name for what is commercially known as KY jelly. But there's also petrolube and all those other kinds of things that you can put on to the packing as you install it. And you always want to try to lubricate the packing whenever you install it, if you can. And most of the time, your AMM, your maintenance task, or manufacturer's guidelines, we're going to tell you to do that, because once they've kind of set up. Keep in mind that most of them are just fluorocarbon rubber. Once they're set up, they are very apt to get torn, or dry rot, or break, or whatever else. And if you have any sort of those defects, if you don't lube it, then the friction of it going on will just simply make it worse. So it's more apt to fail later on. So always try to put some lube, if you can, on there. The rule of thumb is that if it's not called out in the book, and you don't have anything like KY jelly on hand to lube those packings with as you put them on, whatever fluid that it's going to be subjected to, that's what you want to lube it with. So, like, if it's going to be on a hydraulic part, you want to take some of that hydraulic fluid and just run it on there. It doesn't have, it's not going to absorb it or be super wet to begin with. But like just enough to let it glide on and not stick and get torn, or get damaged in some way, shape, form, or fashion. Yeah, so those are a couple of kind of rules of the road with any of them. All right, so let's break down our different types of seals that we could potentially have in a hydraulic or pneumatic system. First off, we're going to talk about the packing or the preformed packing seal O-ring, as it's called in the Textron maintenance manual, which is where I pulled this picture. Now, these in particular O-rings, these particular types of seals are generally used across all manner of. You'll see O-rings everywhere from the engine to hydraulics to anywhere. So this is something that you're going to see on a pretty regular basis. Okay, so one thing to remember about O-rings is that their part numbers really matter. These things are cut to very close tolerances. They're made to be perfectly round, and one part number different, like one digit difference in part numbers, could mean the difference between it actually doing its job and not. Even if the O-ring seems to fit on the application where you're putting it, you don't want to make the poor choice of getting one that's close enough and then thinking that it'll work, because it won't. Either it won't swell correctly, it won't seal correctly, or it'll get damaged and break, or it'll break prematurely. Something will happen. So you always want to make sure you have the right part number for the right job, because this is a game of precision, especially when it comes to O-ring selection. So whatever the IPC calls out, that's what you put on the part. The other thing to keep in mind is that there are actually a couple different standards for O-rings that will be part of their part number. One is the Air Force Navy standard, and they're made to certain specifications, and that's largely going to refer to the type of rubber that it has been manufactured from. Then, as time went on, they started to replace the AN standard with the MS standard, offering an improved low temperature performance without sacrificing high temperature performance, meaning that it didn't shrink so much. And now MCM is starting to become the next kind of innovation of O-ring technology, and so you'll see MCM O-rings that are the equivalent of, and then pick out a AN, NAS, or MS number. And that means that they're made to the same specifications, but it's made from superior material, so it won't expand or contract in different temperatures. Okay, so fun fact about O-rings is that's what caused the Challenger to explode. Essentially, one of the O-rings did not fully expand to create a seal, and without going into all the technical details of it, the subsequent effects led to an explosion of that air, or of that spacecraft. And so even though that you have a multi-million-dollar state-of-the-art machine that's heading up into outer space on the cutting edge, it was literally brought down by a dollar or two worth of rubber in the shape of an O-ring. So don't think that these things do not matter. Sometimes the simplest cog on the machine matters the most, and it definitely did that morning the Challenger exploded. Okay, so the next type of seal that we're going to go over is the gasket. So gaskets are used in a static or stationary seal between two flat surfaces. Some of the most common types of gasket materials are asbestos, copper, cork, and rubber. In this case, this one is copper off of a Cessna fuel tank. All right, asbestos sheeting is used whenever the heat resistance gasket is needed. So, like on a Bell helicopter's aft cowling, where the exhaust comes out, there's like a little thin gasket of asbestos that we would have to like always try to not breathe in the dust that would come off of it. But it would sit between the cowling in the exhaust pan, so that way it didn't the hot exhaust didn't burn the aircraft. So most asbestos exhaust gaskets have a thin sheet of copper edging to prolong their life, and that one did not. However, there are some out there that do, because what they'll do is they'll fray, kind of like carbon fiber will fray, and it'll start to fall apart. So a solid copper washer is used for spark plug gaskets. So whenever we get into power plant, you'll see a copper washer that should be replaced on every single change of the spark plug, because whenever you do that, you compress that little crush washer, and it forms a seal that to enhance the seal of the spark plug to the cylinder, so that way you don't have any blow by or any sort of seal leak or cylinder leakage for that. But those are all different types of gaskets. The key thing to take away from them is that they are stationary. They don't move around or anything. And yeah, so that is gaskets. Okay, so another one or the kind of our last category of seals is a wiper. This is really can be real common, and you'll see in pneumatics whenever we get to it when we start rebuilding struts and things like that. What wipers do is they provide a seal, but they also have kind of a little flange you can see on there that also grabs the excess fluid and pulls it away, just like a squeegee across the hangar floor. It cleans it up really nice and pretty, and make sure that there's no fluid left over. Now, this is important, like on a strut, that you have like good wipers, because if not, what will end up happening is that, like, as the strut decompresses and it leaves some of that metal exposed, there's going to be bits of hydraulic fluid still left on it. That hydraulic fluid will then gather dust and dirt, and then whenever the strut goes to compress again, all that dust and dirt that's being carried by that leftover fluid will go up into the strut and then degrade it. So having good solid wipers helps prevent that from happening. Okay, so here's before we kind of move on, some neat graphics from the 8083 that I think are useful. These are different types of packings. What we talked about was the O-ring packing. That is by far the most common type that you'll have. But you could have other iterations of packings that are out there. They all do the same thing. They're there for the same purpose, but they might take a little bit of a different shape. So, like U-cup is one of the more common ones that you'll see. You'll also see V-rings that are down, and then every once in a while a U-ring. I cannot recall a time that I saw either a male or female packing that are set up like that, but I may have. And those would be diametrically opposed to each other. They would mate up and be they would create their own seal. But no, just know that these things exist out there. You handle them the same way. You do all the same things. And most of the time, if you're going to get a specialty packing like this, it's going to come with specialty instructions inside the AMM or whatever rebuild kit you're working with. Yeah, so just know that. Okay, so another thing that you will come across is backup rings. Backup rings, usually what will end up happening is that you'll install a packing, and then you'll have these white rings that snap on behind it. And all they are is to prevent the O-ring from getting squeezed through or extruded through a gap or a surface. These little plastic rings are generally very hard, and they can't even be difficult to install. This graphic out of the 8083 here will turn around and show you what's the correct way to install them, and it goes kind of without saying is that you'll end up having those two lips on the end of the backup ring basically opposed to one another, so that they would make like a complete ring if they were to touch. And then in the middle, you'll have the O-ring, which will help give it some rigidity. The O-ring supplies the seal and kind of the flexibility that the seal requires. The backup ring requires the rigidity to stand up to the pressure that the O-ring might be faced with, so it doesn't fail. All right, last thing we want to talk about is accumulators. We already understand what they are. Let's talk about the maintenance practices and some of the kind of the best procedures surrounding accumulators. Okay, so the main thing to keep in mind with accumulators is, if you remember from when we talked about them, is that like you have charged air on one side and you have hydraulic fluid on the other. Now, if you need to take this accumulator off, if you need to service it, if you need to take it apart, if there's anything that you need to do with the accumulator, the first thing that you need to do is discharge the air to make sure that it is not fully charged whenever you go to crack a line on here. Because keep in mind, the whole purpose of the accumulator is to deliver very robust, very strong power very, very quickly at the the flip of a switch or the press of a pedal or whatever. And so if you provide a way for that air pressure, or even probably worse, that hydraulic pressure to come out on you, it could very seriously hurt you. There's more than one instances where somebody cracked a hydraulic line that was pressurized or charged, and the hydraulic fluid comes out so fast and so strong that it works like a hydro cutter and basically slices them open. Now that could happen the same way with accumulators. You might want to just simply look at them as like charged bombs whenever their pressure is on, because that's effectively what they are. And then the pressure is then let out in a very methodical way, applied directly to whatever application they're tied to. So the so what is that if you're going to work on or do anything with an accumulator, you need to discharge it first before you're doing anything else to make sure that it's safe, it's inert, and it's ready to be worked on.